Here is a quick summary of what we have learnt in the previous video. Balloon and hair get charged when rubbed together. Balloon gets negatively charged and hair gets positively charged. Like charges repel and unlike charges attract. This force of attraction or repulsion between charged bodies is called electrostatic force. The balloon and hair experiment is a classic example of charging by friction. It is also known as the triboelectric effect. There are many pairs of materials that can be charged this way, but there are also many pairs of materials that don't seem to get charged, or even if they do, the charge is weak. What could be the reason behind this? Why did balloon acquire negative charge and hair positive charge? In a pair of materials, what decides which material will acquire positive charge and which one negative charge? What happens if two bodies made of same material are rubbed? Will they still get charged? Well, to answer all these questions, we need to understand why and how materials get charged on rubbing. When two materials come into contact, sometimes electrons can get transferred from one material to the other due to the difference in their electron affinities. Electron affinity measures how strongly an atom can attract and hold on to an added electron. Think of electron affinity as a grip on electrons. Imagine two kids wrestling over a ball. Who ends up with it? The stronger kid, the one with the tighter grip, will hold on to the ball. Similarly, electrons get transferred from a material with weak electron affinity to a material with strong electron affinity. The electrons that get transferred are the outermost electrons. These electrons can be easily removed or influenced by external forces, as they are far away from the nucleus in comparison to the inner electrons. The two materials only need to come into contact and then separate for the electrons to be transferred. However, the effect is greatly enhanced by rubbing the materials together, as they touch and separate many times. The energy released during friction is utilized by the electron to overcome any obstacles during the transfer. The material which loses electrons becomes positively charged, and the material which gains electrons will become negatively charged. This explains why balloon became negatively charged and hair positively charged. Obviously, balloon must be having higher electron affinity in comparison to hair. Bigger the difference in affinities, more will be the number of electrons getting transferred, hence stronger will be the effect. But if two materials have similar electron affinities, there is no significant transfer of electrons. Therefore, these pairs of materials show weak or no signs of charging. This also explains why two bodies made of same material don't get charged. Both will have same electron affinity, hence there is no transfer of electrons. Now that we have understood charging by friction, let's look at some naturally occurring phenomenon involving this process. Lightning is a striking example of charging by friction. Within the storm clouds, turbulent winds cause ice particles and water droplets to collide and rub against each other, transferring electrons. This process leads to a massive buildup of positive and negative charges in different regions of the clouds. Massive buildup of charges creates an intense electric field which ionizes air, creating a path for charges to flow. A sudden discharge of this built-up charge produces a brilliant flash of light and sound we know as lightning. Another everyday example is a static shock. Have you experienced static shock after sliding out of your car seat and touching the metal door? It's a common occurrence, especially in dry weather. As you slide out of the seat, friction between your clothing and the car seat causes electron transfer, building up a charge on your body. When you touch the metal door, the built up charge on your body quickly transfers to the metal. The sudden discharge causes the sensation of shock. While it is harmless, it can definitely catch you off guard. But there are cases in which static electricity can be dangerous. For example, in industries handling flammable gases and liquids, a small spark caused due to static discharge can ignite an explosion. This is the reason why fuel tankers are equipped with grounding chains or straps that drag along the ground, dissipating static charge safely into the ground. This example highlights the importance of knowing which materials are more likely to get charged by friction. And for this purpose, we have something called as the Triboelectric series. It is a list obtained by ranking materials according to their tendency to gain or lose electrons. We can use this list to predict the direction of flow of charges between two materials on the list. The material higher on the list will lose electrons to become positively charged, and the material lower on the list will gain electrons to become negatively charged. For example, if we rub a glass rod with a silk cloth, the glass becomes positively charged and silk becomes negatively charged. It can also be used to predict the relative strength of triboelectric effect between two materials on the list. The farther the two materials are, stronger will be the triboelectric effect. For example, in comparison to hair and silk, fur and PVC will produce stronger effect. Triboelectric series is a useful tool, but we need to be aware that it is not reliable for precise predictions. It is not reliable because, apart from charge affinity, factors such as surface roughness, duration of contact, and the pressure applied during contact can significantly impact the process of charge transfer, thereby changing the position of the material in the list. Environmental conditions can also influence triboelectric effect. For example, in humid conditions, the water molecules in air act as conductors, allowing charges to dissipate to the surroundings, thereby dampening the triboelectric effect. We have explored the fantastic world of charging by friction. But did you know that charging by friction isn't the only way objects can charge? We also saw the use of grounding as a safety measure for fuel tankers. But what exactly is grounding? In the upcoming videos, we will dive into different methods of charging and uncover the science behind grounding. Stay tuned. Thanks for watching.